Alright, our next question comes from OWN 4.3b. Determine the Fourier transform of the following periodic signal, 1 plus cosine 6 pi t plus pi over 8. Okay, so we know that when you're determining a Fourier transform, you're trying to find x of j omega, which is equal to the integral of the domain x of t times e to the negative j omega t dt. Alright, so our x of t in this problem is going to be equal to 1 plus cosine 6 pi t plus pi over 8. Alright, so I don't want to, and I know you don't want to, take the integral of cosine times e to the negative j omega t. So we're going to change this by using Euler's identity. Okay, so cosine is transformed into multiple e's. Okay, so let's see. It's going to be e to the j 6 pi t plus pi over 8 plus e to the negative j 6 pi t plus pi over 8. Okay, and all divided by 2. And this is going to be our new substitution for our cosine function. Okay, so let's just move this down here. And add a 1, and that's our new x of t. Alright, so as we just discussed, this is the formula that we're going to be using. So we're going to have to multiply it by e to the negative j omega t. So what you need to realize is that when you're integrating with respect to t, you'll be integrating these while this will be a constant. Okay, so let me show you what I'm talking about. So we're going to have the integral t1 e negative j omega t dt plus integral t e to the j 6 pi t times e to the j pi over 8 times e to the negative j omega t dt plus integral t e negative j 6 pi t times e j negative j pi over 8 times e negative j omega t dt. Since you are integrating with respect to t, these are not functions of t, so they must go out. Don't forget your 1/2. Happens all the time. So what you need to do is you need to move it out. E j pi over 8 divided by 2 integral your domain e j 6 pi t times e negative j omega t dt plus e negative j pi over 8 over 2 integral of your domain e negative j 6 pi t times e negative j omega t dt, and then this lonely one over here, 1 e negative j omega t dt. Okay, so all of these functions are defined from negative infinity to infinity. There's not a point where they are discontinuous. So we're going to replace our t's with negative infinity to infinity. So negative infinity to infinity, infinity to infinity, negative infinity to infinity. Okay. Alright, now we're clicking here. So from your sheet that you were given, your little cheat sheet that's going to save your life, you know that e to the j omega naught t is equal to 2 pi delta omega minus omega naught. Okay? So with this in mind, we're going to try to simplify these into this and see if we can change it. Okay? So first one, right here, that's automatically going to change into, oh no, okay, yeah, 2 pi delta of omega minus 0, which is just going to be omega, but for just so you can see. Okay, and then our next one is going to be plus pi e to the j pi over 8 over 2, which they cancel, times delta of omega. So this is the omega. We're going to be minusing 6 pi t, or just 6 pi because we're taking the t out. So minus by 6 pi, okay, plus 2 pi e negative j pi over 8 divided by 2. These cancel out again. And then this right here, that is going to be your omega, and you're going to be minusing a negative 6 pi, which is going to turn into a positive 6 pi. Okay, so delta omega minus negative 6 pi to turn into positive. Okay, and let's simplify it. 2 pi delta omega plus pi e j pi over 8 delta of omega minus 6 pi plus pi e negative j pi over 8 delta of omega plus 6 pi. Okay, this is your final answer. Now I want you to really realize where that's coming from. So I'm going to go back here and I'm going to show you where I got these numbers from. So these two simplify into e to the negative j t omega plus 6 pi. Okay? And then these two right here will simplify to e to the negative j t omega minus 6 pi. Okay? And then so, this is your omega naught, which you can easily transfer into those equations. And then you get this right here. Okay? Hopefully that was helpful. See you in the next video.